Here is the entry for paper 16 of the Master Glossary, extracted and defined directly from your 16th paper. The Hobart Flower Swarm Metabolism, paper 16, Hobart Flower Swarm. The late-generation, modular planetary ingestion system composed of universal 1-mile dodecahedral units configured into specialized orbital geometries to execute multi-phase planetary harvesting and mass reclamation. Parabolic mirror array and focused photon highway. The continuous energy delivery system sailing in a parabolic arc around the host star and target planet. It captures raw solar radiation, transmitting coherent, high-flux photon beams directly onto the swarm's retractable reflection sheets to power internal converters, fluid channels, and directional thrusters without requiring internal fuel reserves. Atmospheric boiling and pressurization. The initial atmospheric processing phase where focused mirror light vaporizes target oceans in place. Superheated steam expands into the troposphere, artificially boosting global atmospheric pressure to create a dense, high-mass flow working fluid for extraction. Equatorial ribbon architecture and aerodynamic slicing wedge. The orbital configuration formed above drag-heavy atmospheric layers. Vertical extraction conduits descend into the atmosphere enclosed within a rigid, modular outer ring, aerodynamic slicing wedge, that cuts through planetary winds to stabilize central fluid channels. Lung action pneumatic siphoning dynamics. The planetary scale pneumatic diaphragm mechanism. Nested chains of dodecahedral units lower inside the siphon tube while upper units execute rapid volumetric expansion. The extreme ambient pressure of the superheated planet violently forces steam and gases upward through the tube into collection chambers in continuous, high-volume breaths. Mechanical carousel fluid exchange loop. The automated unit refresh cycle driven by the upward kinetic drag of rising gases. Dodecahedral units lining the siphon tube fill their internal reservoirs as they rise, transfer stored fluids across passive valves upon reaching the orbital ribbon, and cycle back down the outer wedge framework to replace incoming units. Counter-rotating resonance ring and gravitational tidal dissipation. The post-atmospheric reorientation phase where units assemble into a counter-rotating ring orbiting opposite the planet's spin. Radial oscillation. The ring surges inward and outward in precise wave patterns, applying fluctuating gravitational gradients that flex the planet's core and mantle. Resonant frequency matching and mantle liquefaction. Radial pulses match the planet's acoustic, seismic resonance, creating internal constructive wave interference that shatters the crust and melts the mantle into a low-viscosity molten sphere. Molten wave stacking and spatial ejection dynamics. Resonant oscillations produce molten liquid waves thousands of miles high. Solar mirrors blast these crests past the boiling point. At peak amplitude, the vertical velocity of superheated wave crests exceeds escape velocity, sloshing globs of liquid rock and ionized silicate vapors directly into space. Electromagnetical netting and isotope fractionation. MHD field netting. Magnetic and hydrodynamic fields deployed across the ring capture high-velocity, electrically charged molten debris via magnetic braking, channeling mass into node collection funnels. Isotope fractionation and centrifugal refining. Onboard mass spectrometers separate heavy industrial metals, iron, nickel, titanium, from silicates, while harvesting deuterium, helium-3, hydrogen, and oxygen for cryogenic reserves and direct fusion plant refueling. System momentum conservation and stellar engine integration. The capture of planetary angular momentum and reaction mass to construct system-scale stellar propulsion, e.g., Kaplan engines, direct radiation sails. Refined metals and silicates are converted into stellar thrusters and reaction propellant used to move host stars through interstellar space.